Hi, this is David Desert of Pancanology. In this video, I want to show you why chemotherapy stops working. And once we know why, we can talk about some ways we can use this information to our advantage. We'll start with a single tumor cell and track it as it divides and grows into a large tumor. The first fact that we should know is that tumor cells make more mistakes than normal cells when they divide. Most of those mistakes result in cells that don't survive. But occasionally one does, as we see here by this new red cell. It's still a cancer cell, but just a little different than the ones before. Sometimes those mistakes result in a more vigorous type of cancer cell. Along the bottom here, we're tracking the size of the tumor over time and the relative quantities of each cell type by color. When a mistake results in a more vigorous cell, it reproduces faster than the others. Sometimes less vigorous cells get outcompeted for resources and may even die out, but overall the tumor grows in size. We say that the tumor is heterogeneous because it is made up of a variety of similar but not identical cells, represented here by different colors. Let's stop it here for a moment. Now we're going to treat this tumor with chemotherapy. Because the tumor cells are not all the same, some of them are affected more or less by chemotherapy. Chemotherapy could kill some quickly, have no effect on others, or even spur new cells that depend on the chemotherapy being present. Here we're going to use a yellow chemotherapy, and it will be fairly effective against the yellow cancer cells in this picture. Each time we treat this tumor, some more of the tumor cells that contain yellow die off. After a while, most if not all of the yellow tumor cells are gone. While we had some good tumor shrinkage in the beginning, the chemo-resistant cells continued growing and spurred the development of newly mutated cells. The tumor has started growing larger again, which is why we're stopping this treatment and need to find another one. But the tumor composition is also very different. If we compare the tumor before and after treatment, you'll notice that the tumor has changed quite a bit. What would happen if we could sample a piece of the tumor and select a treatment based on what we find? This is the idea behind having a tumor biopsy and using molecular and genetic information to pick a promising treatment. Or imagine if we treated the tumor with multiple chemotherapy agents that work in different ways or against differently colored cells. This is why we have moved to combination treatments, using multiple drugs. Or what if you could find a fundamental characteristic that all the tumor cells shared that we had a treatment for? This is the idea behind germline mutations such as BRCA1 or BRCA2 and platinum chemotherapies. I'll explore each of these ideas in future animations. Thanks for watching this video on why chemotherapy stops working. Many things I'll talk about may seem negative, but I believe that understanding will give us insight into how we can make better treatment choices, including sampling the tumor, genetic testing, clinical trials, and even chemotherapy.